All right, 10 of multiplying and dividing radical expressions. So we're going to look at multiplication. You add the square root of 3 times, open parenthesis, 4 plus the square root of 5. So this is like what, distributive property? When you multiply, you would need to multiply the square root of 3 times 4 and the square root of 3 times the square root of 5. Now the thing with multiplying is, if you notice, 3 isn't a radical, square root of 3, and then 4 is a whole number. You can't make that 12. You would just write it together because they're not the same types of numbers. One is a radical number, one is a whole number. So when I multiply that, that's 4 square roots of 3. Does that make sense? Now, in order for it to combine an actual multiply, they both got to be whole numbers or they both can be radical numbers. Like when I say the square root of 3 times the square root of 5, then that comes together and makes the square root of 15. Do you see the difference? The first one would just be simply writing it together because 1 is not a radical. 4 is not a radical. Does that make sense? Now, before you say, okay, that's my answer, you got to make sure those radicals are in lowest terms. Square root of 3, nothing you can do there. Can you break down the square root of 15? What perfect number is in 15? Keep in mind, in order where you can break something down, it has to have a perfect number. Does 15 have a perfect factor? No. It only has 2 factor pairs. 1 and 15 and 3 and 5, and they ain't on your yellow sheet. Okay? So this would be your answer. You can't do nothing with the square root of 15. So does that make sense? But always check to make sure it's in lowest terms. Okay? What if we had the square root of 3 times the square root of 12 minus 4 in parentheses? So when we distribute, the square root of 3 times the square root of 12 is what? The square root of 36. But what is the square root of 36? 6. It's 6. Okay? And then we have the square root of 3 times negative 4 is just what?
Negative 4 square root of 3.
And can you do anything with the square root of 3? No. Can you even subtract those two? No. Just like on the first one. They got to have the same what? Radical. We talked about that on Monday. They got to have the same radical. So that too would be your answer. That's all you can do is say 6 minus 4 square roots of 3. Does that make sense?
Subtracted if the 6 had a radical, right?
Right. If 6 had square root of 3 on it.
Okay.
Right. They have to match. What about the square root of 2 times the square root of 18 minus the square root of 3? Okay. When we distribute, that would give us what? The square root of 36 minus the square root of 6. And what do you know about the square root of 36?
6.
It's 6. Can I do anything with the square root of 6? No. So you just bring it down. 6 minus the square root of 6. Okay. What about 7, open parenthesis, square root of 50 minus the square root of 18? distribute, and you will have what?
7 square root of 50 minus 7 square root of 18.
Okay, 7 square root of 50 minus 7 square root of 18. And then what? Are you done? What did we talk about on Monday? Now, in order to add or subtract, now both of these got two radicals on it, but are your radicals in lowest terms? No, so you can't leave this one like this. Now, this is different than me having a square root of 6 left over or a square root of 3 left over. You see, those don't have no perfect numbers. They're in lowest. But a 50 and an 18, you should automatically now know that has a perfect number in it. What's in 50? Very good. 25 times 2. And then 9 and 2 in the 18. Good. So we know we did this on Monday. How are we going to break that? Be the square root of 25 changes to 5 times it by 7. Good. It makes that 35 square root of 2. Good. And then we said the square root of 9 changes to 3 times that negative 7. Negative 21 square root of 2. Do you see how this incorporates Monday lesson? You're adding and subtracting. You can't forget that. So now, can you actually subtract this one? Yes, they got the same radical. So 35 minus 21, 14 square root of 2 is our answer. Do y'all see that? Okay. Number 5. 5, open parenthesis, the square root of 72 plus the square root of 8. Okay. Okay. Square root of 36 times 2. And then the second one is going to be what? 4 and 2. Okay, so the square root of 36 times 5, square root of 2, and the square root of 4 times 5, square root of 2. And now can you add these together? Yes. So we have 30 plus 10, which is 40 square root of 2. Do y'all see that? Go back and look at number 4. Okay. Number 6. Open parenthesis, the square root of 3 plus 2, close the parenthesis, times, open parenthesis, square root of 6 minus 5, close the parenthesis. Now this is 2 binomials times each other. So you might be familiar with the term FOIL, it's the same thing. Or you're going to take the first parenthesis and you're going to take that square root of 3 and multiply it times both pieces. Then you're going to turn around and take 2 and multiply it by both what? Pieces in the second, okay? So it's still like distributive property, you just got to do for both of them. So the square root of 3 times the square root of 6 makes that the square root of 18. Now we're just going to write everything down and we're going to come back and look at the stuff we need to reduce, okay? Square root of 3 times negative 5.
Is negative 5 square root of 3.
Awesome. Then we multiply by 2. 2 times the square root of 6. 2 square roots of 6. And then 2 times negative 5.
Negative 10.
Negative 10. Do y'all see that? So now, starting with the first radical, can it be reduced? Square root of 18. Yes, what perfect number is in 18? 9, good, times 2. So the square root of 9 is 3. Now, is there a number outside it? No, so that's just going to be 3 square roots of what? 2. Now, is there anything else? Can I reduce the square root of 3 on 5 square root of 3? Can I reduce the square root of 3? No. Can I reduce 2 square roots of 6? No. So I'm going to just bring everybody down. Now, let me ask you this. Can you combine anybody? Do you have any of the same stuff? No. Ain't they? None of them have the same radical. Okay? So that's your answer. So don't try to combine stuff. You might can't combine nothing. Because all of them got something different. You got a whole number, radical 6, a radical 3, and a radical 2. They all different. Does that make sense? Okay. Let's look at number 7. Open parenthesis, the square root of 7, plus 1, close the parenthesis, times, open parenthesis, square root of 2, minus 4, close the parenthesis. Same setup. We're going to multiply by the square root of 7, and then we're going to turn around and multiply by 1. So, square root of 7 times the square root of 2 is what? Square root of 14. Square root of 7 times negative 4. Good. Negative 4 square roots of 7. Now, if you multiply by 1, 1 times square root of 2 is just good. And 1 times negative 4. Very good. Now look at each radical. Square root of 14. Is there a perfect number in 14? No. His only factor is 7 and 2, and they ain't perfect. 7, can you break down the square root of 7? Can you break down the square root of 2? Do you have anybody that's alike that you can combine? No. So that's your answer. Do y'all see that? Okay. Number 8. Open parenthesis, square root of 2 plus 5, close the parenthesis, times the square root of 2 plus 7, close the parenthesis. Same setup. We're going to multiply by the square root of 2. Then we're going to turn around and multiply by 5. So the square root of 2 times the square root of 2 is what? Square root of 4. Square root of 2 times 7? 7 square roots of 2. Now multiply by 5. Good. 5 square roots of 2. And then 5 times 7. 35. Good. Now, what's the square root of 4? 2. So that's just whole number 2. Okay. Now, what do you notice this time? You can combine. Yes, you can combine. You can combine 7 square root of 2 plus 5 square root of 2. Because don't they both have square root of 2? And that gives us 12 square root of 2, right? Is there anything else?
Plus 37.
Good. You can combine. No, these are whole numbers. Do y'all see that? The 2 and the 35? So that's 37, right? And I'm putting it in the front. I always put my whole numbers in the front. So that's 37 plus 12 square root of 2. Do y'all see that? So I don't want you to think they always don't add up. You can add up sometimes. You can combine some stuff. Now, I wanted to point out when I multiply, and this is the first time I really have shown this, but anytime you multiply a square root times the exact same square root, that's going to always be whatever the number is under the house. Because it counts, the houses cancel out each other. You can tell me it's the square root of 4, but that's still going to give you what? 2. If I was to give you the square root of 3 times the square root of 3, yeah, that's square root of 9, but that's still what? 3. So you can kind of skip that step. Does that make sense? Anytime you multiply the same square root times itself, I can do the square root of 5 times the square root of 5. That's just going to give me what? Well, yeah, the square root of 25, but what is it? It's 5. Does that make sense? It's going to give you that number. Even if you step out there with a variable, square root of x times the square root of x is just going to be x. Okay? Yes, Jackson, it's going to be x squared, and 2 goes into 2 one time. But I'm letting you know, anytime you multiply times itself, the house is going to disappear. Okay? Let's look at number 9. If we were to have the square root of 7 minus 11 in the first parenthesis and the square root of 7 plus 8 in the second parenthesis. So when we multiply square root of 7 times the square root of 7, that's just going to be 7. Okay? You can write 49, and then you got to know it's going to be 7. I'm taking out a step. That's 7. Square root of 7 times 8. Good. Negative 11 times the square root of 7. And then negative 11 times 8. Negative 88. Do y'all see that? So can you combine some stuff? Yes. Your whole number, you got a positive 7 minus 88. That's a negative 81, right? Okay. And then 8 square root of 7 minus 11 square root of 7 is?
Negative 3 square root of 7.
Very good. So that's your answer. Do y'all see that? Questions? Not too bad? Okay. What if I had parentheses, square root of 5 minus 4, and then I put the squared on it?
You just do it 2 times.
Good. You got the same parentheses 2 times? Awesome. But you still got to do what?
You still got 4.
You got to pull it. Still got to multiply it out, but that just means you got the same thing twice. Very good. Square root of 5 times the square root of 5? 5. Good. Square root of 5 times negative 4? Good. Negative 4 times the square root of 5? Negative 4 times negative 4? Positive 16. Very good. So we got 5 plus 16? 21. And then -4 minus 4? Square root of 5. Very good. Y'all see that? Okay. 11. Yeah, 11. Square root of 11 plus 1 squared. Same thing twice. Okay. Square root of 11 times the square root of 11. Huh?
121.
Oh, which is what?
Oh, yeah.
11. Square root of 11 times 1. Square root of 11. 1 times square root of 11. And then 1 times 1. 1. Good. So we got 11 plus 1. 12. 12. 2. Good. 2 square roots of 11. Very good. There's ones technically in front of them. You got 2 of them. So 1 plus 1 is 2. Does that make sense? Okay. What if we had the square root of 6 minus 5 times the square root of 6 plus 5?
That'd be 6.
6.
6, and then 5 in the square root of 6.
5 square roots of 6, okay.
And negative 5 in the square root of 6.
-5 square roots of 6.
25.
And -25. Awesome. So we got 6 minus 25 negative 19. And then what happens with your 5 square roots of 6? They cancel out. Very good. So you only have -19 as your answer. Now this is kind of like the term difference of squares, and we use that back when we factored. But anytime you multiply the same jump, but different signs, your middle gonna cancel. Do you see that? Your middle cancels. So I've told some students, especially like in my college algebra class, you can just multiply the first 2 together and the last 2 together, because that whole middle cancels out. If you don't see it, write it all out. I'd rather you write it all out and get it right. But this will always produce a whole number. You won't have a radical on this one because you have opposite signs. Okay? But the key is it's got to be the same numbers. Square root of 6 on both. 5 is on both. It's just I got different signs. Okay? What if we had the square root of 13 plus 2 times the square root of 13 minus 2? Would the same thing happen on this one? Would our middle cancel? Yes. Same stuff, different signs, my middle will cancel. So when you go to multiply the square root of 13, good, minus 2, and then you got a plus 2, square root of 13s, and then the last is a -4. And do you see you got 13 minus 4, which is 9, but do you see that this middle is going to be 0? Do y'all see that? So you're only left with that number. And that will always be the case. Do y'all see that? All right. Let's look at a couple division. If you were to divide 7 divided by the square root of 2. I'm going to show you monomial, and then I'm going to show you a binomial. 7 divided by the square root of 2. Now, in algebra, it's technically illegal to have a radical on the bottom. So you got to get it off. And that is what we call in algebra rationalize the denominator. Okay? Rationalize the denominator. How you do it is very simple when it's just one term down there. If I can't have the square root of 2 on the bottom, no square root, but this one's square root of 2. I want you to think what we was just doing in multiplication, and I want to make a point of saying it. I need that bottom to turn to a whole number. So it's the only way I can make that bottom turn to a whole number if it has a square root of 2 on the bottom. What must I do? How can the square root of 2 change to a whole number?
Multiply it by the square root of 2.
Bam, there you go. There you go, Tori. Multiply it by the square root of 2. That's why I was going ballistic when y'all trying to give me all this. This is important, okay? Anytime in multiplication, when you multiply by the same radical, same square root, let me clarify, don't work with cubes, same square root, it's going to always produce that number, make a whole number. Does that make sense? So in order for the square root of 2 to just magically change to a number, I got to multiply by the square root of 2. And what you do to the bottom, you got to also do to the what? Top. They go together. Very good. So that's rationalizing. You're going to take the square root of 2 and multiply it times the top and the bottom. So that just gives us what on top? 7 square roots of 2 over 2. Whole number 2, no radical. Okay, I have no radical on the bottom. Does that make sense? That's your answer. Okay. What if we had 15 over the square root of 3? How we get rid of the square root of 3? Multiply by square root of 3. So on top, that would give us 15 square roots of 3 over who? 3. Are you finished on this one, though? What's the difference between 14 and 15? What am I looking at when I ask you, are you finished? 15 and 3 itself. Do you see this? They're whole. They're not inside no radical now. They are actual whole numbers. Can they be reduced? Yes. 3 goes into 15. So that's going to be 5 square roots of what? 3. Do y'all see that? 7 and 2 didn't have nothing in common, so I didn't even mention on 14. Do you see the difference? Okay. So you do need to look to see if the fraction reduces once you've taken care of that denominator. Okay. What about 6 divided by the square root of 2? Multiply by square root of 2. So that will give us 6 square root of 2 over, and are you done? No.
That'd be 3 square root of 2.
Very good. That will give me 3 square roots of 2. Do y'all see that? Three square roots of 2 over the square root of 11. What we gonna do? I didn't hear you. Same thing. Multiply by the square root of 11, right? Now, what will that give us on top?
So 23 square root of 22.
Give me all of it now.
3 square.
3, good. Square root of 22. The only things you can multiply together are two radicals. The square root of 2 and the square root of 11 make 22. But you gotta write that 3 in front. Does that make sense? Over 11. Now check 22. Is there a perfect number in 22? I said perfect number. No, when I say perfect, I mean 4, 9, 16. By now, those should be in y'all's head. 4, 9, 16, 36. Does those numbers divide into 22? No. So it don't reduce. That's why I make sure, even though you multiplied, you still got to make sure it's in lowest terms. Does that make sense? And then 3 and 11 obviously don't have anything in common. All right. What if we did, you had the square root of 10 over 3. So you do know this is the square root of 10 over the square root of what? 3. Which that just, all I did was break it down. I haven't finished it now. Well, I still got to do what?
Multiply by the square root of 3.
Good. Multiply by the square root of 3. And so what does that give us on top? Over 3. Now the square root of 30, is there a perfect number in 30? No. No. 4, 9, 16 don't go into 30. Okay? So you keep it under the radical. And you do know you don't divide 3 into 30. That's a square root number. Whole number and square root number. You never mix them. Okay? So that's your answer. All right, now let's look at binomials on the bottom. 3 divided by 4 plus the square root of 5. 4 plus the square root of 5. All right. Now, the whole division is the same. When I gave you one radical on the bottom, you multiply by that radical to make it disappear. Now you got a radical and a number on the bottom. I still got to make the radical disappear, okay? But I need you to go back to when I was doing my multiplication problems. How does a whole binomial change to a whole number? Because that's what I need is a whole number. I can't have a radical on the bottom. It has to just be a whole number. When I multiplied, how did one of my answers change to just a whole number? Come on, y'all. How did it change to just a whole number? I worked a couple multiplication, probably 2, and it changed to a whole number. How?
You have 1 negative, 1 positive.
Very good. You got to multiply by the opposite. Same jump, opposite signs. When we did here, do y'all see this one? Same binomial, but one's a positive and one's a negative, and my answer comes up to be a what? Whole number. Do y'all see that? That's what I need. I need a whole number. I can't have a radical on the bottom. So I got to be able to multiply by something. See, this is the same stuff, different signs, that makes me have a whole number on the bottom. That $10 word is called a conjugate. Give me out some vocabulary. It's called a conjugate. So you're going to multiply by 4 what? Minus the square root of 5. Now, if you do it to the bottom, you got to do it to the top. Do y'all see that? You multiply by the opposite sign of what's on the bottom. Now, what I would do, I would put that top in parentheses, and you can put all the binomials in parentheses and make it look better to you. But on top, I would not go ahead and distribute that 3 just yet. I would just write it outside the parentheses of 4 minus the square root of 5. Because I need y'all to think futuristic. 3 is a whole number. You're going to have a whole number on the what? Bottom. They could do what? Reduce. Top and bottom. They could reduce. Not saying it always happens, but you don't want to have to distribute the top back out. So I would wait to multiply 3 times 4 and the negative square root of 5. I would just write it together. Does that make sense what I'm saying? Because I could get a 12 on the bottom. If that's the case, 3 goes into 12. Does that make sense? Because the whole bottom going to be a whole number. Now, here, I do want y'all to get to the point of seeing first times first and last times what? Last. I don't want you to have to do the full 4 because the middle is going to do what? Cancel out. You're not going to have a middle. Okay? So what's 4 times 4? 16. It's going to automatically have to be a negative because they're opposite signs. And what's the square root of 5 times the square root of 5? 5. Right? That's the purpose of me doing this, to get 5. And then what's 16 minus 5? 11. Now I didn't get 12, so they don't reduce. 3 and 11 don't reduce. Now honestly, I will take that answer. That's correct. It's in lowest form. Or my last, sometimes they go back and forth. They'll take this answer, or if they say it's in the wrong form, then you need to go ahead and distribute the 3. Okay? That would make that what? 12 minus 3 square roots of 5 all over what? 11. Do y'all see that? All I did was multiply 3 inside. Does that make sense? Wasn't bad, was it? You multiply by the opposite. All right, number 20. Twelve divided by, my bad, the square root of 6 plus the square root of 3. What we going to have to multiply by?
Square root of 6 minus the square root of 3.
Very good. The square root of 6 minus the square root of 3. Does that make sense? Has to be the opposite of that sign on the bottom. Okay, so I would do 12 times, in parentheses, square root of 6 minus the square root of 3. Because the bottom is going to be a what? Whole number. So if you want to put this in parentheses, you can, if that makes it look better. But you're going to say the square root of 6 times square root of 6, and then the square root of 3 times square root of 3. So that would just be what? 6 minus 3, which is a 3. Right? And then